So combining the integrals, you will get integral 0 to infinity e raised to minus p s plus t f of s gt ds dt. Now you have the inside integral. So first integral is with respect to s and the second integral is with respect to t. Now in the first integral, so I'm using the substitution s equal to x minus t. So x will be equal to s plus t varum. Okay, so and again, so x will be equal to s plus t and ds will be equal to dx. Now we have s varying from 0 to infinity. So x will vary from t to infinity now. So you will get integral 0 to infinity. Then replacing this integral in terms of x. So you will get integral t to infinity e raised to minus px varum f of s becomes x minus t, then ds is equal to dx g of t dt. So therefore we can write the integral as integral e raised to minus px f of x minus t g of t dx dt. Now what we do here is we will now reverse the order of integration here. Here the order of integration is dx dt, and let us look at what happens when we reverse the order of integration. ഇനി നമ്മുടെ ഇത് x ന്റെ ആക്സിസ് ആയിട്ട് എടുക്കുക, ഇത് t ആക്സിസ് ആയിട്ട് എടുക്കുക. So here x is varying from t to infinity. So x is varying from t to infinity and t is varying from 0 to infinity. So this is our region. So x in the variation idana x equal to t nu parayna line. So x is varying from t to infinity. So that is this portion, and t is varying from 0 to infinity. So reversing the order, first we will take the limits of t. So t will be varying from, this is t equal to 0, here you have t equal to x. So t will vary from 0 to x when you reverse the order, and x will be varying from 0 to infinity. So upon reversing the order, you will get integral 0 to infinity 0 to x e raised to minus px f of x minus t g of t dt dx varum. Ini first integral is with respect to t. E raised to minus px t illa, so that can be taken out of this integral. So you will get integral 0 to infinity e raised to minus px. Then first remaining integral will be so that will be integral 0 to infinity e raised to minus px into integral 0 to x f of x minus t g of t dt dx varum. So this is dx. And now this integral denotes a convolution integral. So this is f star g of x dx. So therefore this integral actually denotes the Laplace transform integral of Laplace transform. So this is a Laplace transform of f star g. So therefore we started with f of p into g of p. So that will be equal to the Laplace transform of f star g. So from this result again, so if you want to find L inverse of fp into gp, so that will be equal to f star g. So that will be the integral 0 to x f of x minus t g of t dt. So that is going to be the convolution integral. So let us see a few problems on condition. So we need to calculate L inverse of 1 by p square into 1 by p square plus 1. So L inverse of 1 by p square will be, ഇപ്പോൾ നമ്മൾ എക്സിന്റെ ലാപ്ലാസ് ട്രാൻസ്ഫോം എടുക്കുമ്പോഴാണ് 1 by p square വരുന്നത്. അതുപോലെ L inverse of 1 by p square plus 1 is equal to sin x. So L inverse of this is in the form Fp into Gp will be equal to F star G. So therefore here L inverse of 1 by P square into 1 by P square plus 1 will be equal to X star sin X varum. So that will be integral 0 to X. So you will have f of x minus t, so that is x minus t, g of t, sin t dt. So that is equal to x minus t into minus cos t varum minus 1 into minus sin t from 0 to x. So you will get minus of x minus t cos t minus sin t from 0 to x. So at x this will be 0. So you will get minus sin x. Then at 0, so you will get minus x varum. So that will be equal to x minus sin x. So that is the value of L inverse of 1 by P square into P square plus 1. Now the convolutions are also used to, this property of convolution is also used when you solve for integral equations. So suppose you have an equation of the form, so let us write it as a problem. Use a Laplace transform to solve the integral equation. So y of x is equal to x cube plus integral 0 to x sin x minus t y of t dt. So this is an equation which involves integrals. So here x is the independent variable and y is the dependent variable. Our aim is to solve for the value of y. So this is an equation which involves integrals. So these type of equations are called integral equations. ഇനി ഇവിടെ വരുന്ന integral എന്ന് പറയുന്നത് നമ്മുടെ convolution integral ആണ്. So let us see how to solve for this equation. So solution is obtained by taking Laplace transform on both sides. So taking Laplace transform on both sides. So we are going to get, so this is L of y, that will be equal to L of x cube will be 3 factorial by p raised to 4 plus, now this will be the convolution integral. So this is L of f star g formula. So that will be equal to fp into gp. So that is L of sin x into L of y varum. So that is L of y will be equal to 6 by p raised to 4 plus L of sin x എന്ന് പറയുന്ന 1 by p square plus 1 L of y. So therefore L of y is equal to, okay, into 1 minus 1 by p square plus 1 will be equal to 6 by p raised to 4. So therefore L of y into the p square by p square plus 1 varum equal to 6 by p raised to 4. So therefore L of y will be 6 p square plus 1 by p raised to 6 varum. So that will be equal to, so that implies L of y will be equal to 6 into 1 by p raised to 4. Okay. 6 into 1 by p raised to 4 plus 1 by p raised to 6 varum. Now 6 by p raised to 4 plus 6 by p raised to 6. So therefore y will be L inverse of, so this is 3 factorial by p raised to 4, 3 factorial by p raised to 6. So inverse transform എടുക്കുമ്പോൾ this will be x cube. ഇവിടെ x raised to 5 ന്റെ ആയിരിക്കണം വരുന്നത്. So you will have 1 by 20 x raised to 5. So that is the required value of y. Now let us look at one more problem. Finding L inverse of 1 by p square plus a square whole square. Now L inverse of a by p square plus a square will be equal to sine ax varum. So L inverse of 1 by p square plus a square whole square can be written as 1 by a square L inverse of a by p square plus a square into a by p square plus a square. So by convolution this will be sine ax star sine ax varum. So that will be 1 by a square integral 0 to x sine a x minus t into sine at dt varum. So this will be the integral. Now this is in the form sine a sine b. So that will be 1 by 2 a square integral 0 to x. Now sine a sine b എന്ന് പറയുന്നത് cos a minus b. So that is ax minus at minus cos a plus b varum. So that is ax minus at plus at dt. So you will get 1 by 2 a square integral 0 to x cos ax minus 2at varum minus cos ax dt. So upon integrating you will get 1 by 2 a square and sin ax minus 2at by minus 2a and minus cos ax, here integrating with respect to t, but this is considered as constant, but t cos ax varum. So apply the limits from 0 to x. So you will get 1 by 2a square sin minus ax by minus 2a minus x cos ax minus sin ax by minus 2a. So when you simplify you will get 1 by 2a square sin ax by 2a minus x cos ax plus sin ax by 2a. So that is 1 by 2a square sin ax by a minus x cos ax. That will be the required inverse transform.